Oh, you know what? Let me pull up this second screen here so we can share. All right, class, we're about to start section 1-1. It's on page 3 of your course pack. Now, for those of you that are new to this class, you need the course pack. I believe the cover of your course pack looks like this here, Math in Our World, Quantitative Literacy Approach. And you need to go to page 3, which says given 110%. We have our learning objectives. We are to perform conversions and calculations involving percents, find percent increase or decrease, solve problems using percents, and evaluate the legitimacy of claim based on percents. Now, at the bottom here, it says, surely you're familiar with the word percent, but have you ever thought about what it literally means? Percent can be translated literally as per 100. So 1% is 1 over 100. For example, the International Mass Retail Association reported that 20% of adults plan to buy Valentine's Day cards next year. Of those who plan to buy them, 36% of women and 26% of men plan to buy romantic cards. This tells us that 20 out of every 100 adults plan to buy a card. Also, 36 out of 100 women who buy a card will choose a romantic one, and 26 out of 100 men will do so. Percent conversions. To work with percents and calculations, we would need to convert them to either decimal or fractional form. But to interpret the answers to calculations, we would want to convert them back into percents. So we come here to page 4, problem number 1. It says, using the fact that percent means per 100, write 84% and 9% as fractions with denominator 100. Now they're not asking us to simplify here, so they just want us to keep the denominator as 100. So it'll be 84 over 100, and then 9% will be 9 over 100. Now it says here, here's a simple rule that can be learned from question 1. Converting a percent to a fraction. To convert a percent to a fraction, drop the percent sign and use the percent number as the numerator of a fraction whose denominator is 100. Now it says here, if you notice that the fraction in the first part of your answer to question 1 could be reduced, good job. When we're working with percents in fraction form, many times it will be easier if the fraction is reduced to lowest terms. So now we have 42%, which will give us 42 over 100. Now, traditionally in math classes, we would basically tell you you need to simplify this problem, and typically you would be dividing by some value. But because we have the Desmos calculator, we could actually let Desmos simplify this for us. So we could type in 42 divided by 100. Now they gave us the decimal, but they want this as a fraction in lowest terms. So what you would do on Desmos, you see this fraction here, you would click this here, and it would give you the simplified fraction. So this will be 21 over 50. Now we look here at B. 37.5%. Hint, after initially writing as a fraction, now we don't have to do this, but if you choose to do it, that's fine. It says multiply by 2 over 2 so that the numerator and denominator of your fraction are both whole numbers. But this is what we could do. 37.5, we know a half is 0.5. So really this is 37.5%, which we could rewrite as a fraction, 37.5 over 100. We could put that right into the Desmos calculator and then hit our button here, and it will give us the fraction of 3/8. Now, when you are taking your exam, you can use Desmos as well. So just to let you know that you can have access to this. Okay, now for number 3, it says often it's especially useful to write a percent in decimal form when doing calculations. So let's see how that works using what we already know about fractions. So number 3, we know that we can write 12% as a fraction in the form 12 over 100 and 72% in the form 72 over 100. Use a calculator to perform the division in each case, writing the original percent in decimal form. So basically they want us to do 12 divided by 100, and that gave us 0.12. So we could write down 12% is equal to 0.12, and then 72%, 72 divided by 100, that'll give us 0.72. And we're done. Now, we move on to the next page. It says for number 4 here, use the result of question 3 to fill in the blank in our next rule for converting percents. It says to convert a percent to a decimal, drop the percent sign and move the decimal point 2 places to the left. Now, just to illustrate that, going back here, when we had 12%, we dropped the percent sign. It's always assumed to be a decimal at the end of a whole number. Drop the percent sign and move that decimal 2 places to the left. We did that for the 72% as well. So that's just a rule that could come in handy. Now, for number 5, it says write each percent in decimal form. Now, we could drop the percent, move the decimal 2 places to the left, be 0.41. Now, 6.7%, drop the percent, move it 2 places to the left, be 0.067. And then finally, 120%, drop the percent, move it 2 places to the left, and it'll be 1.2. So, here's another thing that you may want to take a look at. Say you're doing a test and you just don't remember that rule. We know percent means over 100. So we could just take 41 divided by 100. It gave us a 0.41. 6.7 divided by 100 gave us a 0.067. And then 120 divided by 100 gave us the 1.2. Now, sometimes interpreting the story told by a percentage will require a conversion in the other direction. Starting in decimal form and converting to percent form, not surprisingly, we accomplished this by doing exactly the opposite of the steps we did for converting from percent to decimal form. The opposite of moving a decimal 2 places to the left is moving the decimal 2 places to the right. They did not give us enough room to write in that blank. The opposite of dropping a percent sign is adding a percent sign. Now it says here for number 7, write a procedure for converting a decimal to percent form. Then use it to convert 0.34, 0.07, and 1.658 into percent form. Okay, so the procedure would be to move the decimal, move decimal to the right 2 places, and add a percent at the end. of the value. Okay, so in taking this here, we want to take 0.34, and that's equal to, I'm going to write 0.34 again, but this time I'm going to show the movement of the decimal, and then this will be 34 and add the percent at the end. Then we would take the 0.07, move the decimal 2 places to the right. That'll leave us 7 in percent at the end. Last but not least, 1.658. Move the decimal 2 places to the right. It'll be 165.8%. And we are done with this page. Now again, if you have any questions, please feel free to ask. All right. On our next page, which is page 6, it says in the most common calculations involving percents, the goal is to find a percentage of some quantity. To understand how to do so, consider the following example. You probably know that 50% of 10 is 5. Let's rewrite that statement, then turn it into a calculation. 50% of 10 is 5, and 0.5 times 10 is 5. When writing a percentage statement in symbols, the word of becomes multiplication, and the word is becomes an equal sign. Also, we need to change the percentage into decimal or fractional form. Let's look at some sample calculations using this idea. A restaurant was running a fundraiser tonight for the local food bank in which 30% of every purchase was donated for food relief. If my wife and I spent $24.59 at the restaurant, how much was donated? So it says fill in the blank to describe the calculation described above. So basically, it tells you here 30%, so that'll be 30, of every purchase. Now the purchase here was $24.59. 30% of $24.59 is what amount? Okay, so we look here at number 9. What was the amount donated? So we would change this into an algebraic problem. So this would be 30%. We have to change the percent to a decimal. So it'd be 0.30. Of means multiplication. And you have your $24.59. Is equal, and what amount is X? Now, when we multiply this here, we can put this in our calculator. 0.30 times 24.59, and that would give us approximately $7.38, because we typically don't go 3 places behind the decimal point with our money. Now, the same idea can be used for other calculations involving percentages, like this one. A closeout store is advertising leather jackets at 70% off the original price, which means the sale price is 30% of the original price. If one jacket has a sale price of $59, how much did it cost originally? Now it says fill in the blanks to describe the calculation described above. Said blank percent of what amount is blank. Okay, so first of all, it tells us that the sale price is 30% of the original price. So it'll be 30% of what amount. We don't know what the original price is, so that'll be the what amount is, and 30% of that, the new price would be $59. So now number 11, based on your answer to question 10, set up and solve an equation to find the original price of the jacket. So we have, I'm just going to write this out first, 30% of some unknown value, because what amount would be our X, is equal to $59. Now we change this 30% to a decimal, which would be 0.30. Of becomes multiplication. X is X. And I should have wrote the word is here. But this should be is. And then is will be equal. And then it'd be $59. Okay, now we would divide each side. We have 0.30x is equal to $59. We divide each side by 0.30. So we can put that in our calculator. 59 divided by 0.30. And that gives us 196. So that would give us x would be approximately $196.67. Because remember, we only round to 2 places behind the decimal. So that was the original price of the jacket. Now we move on to the next page. It says here, guess what? The same idea can be used to find a percentage, but it's a more straightforward to use division. For example, of the 32 teams in the National Football League, 12 make the playoffs each year. What percentage of teams make the playoffs? It says divide the number of teams that make the playoffs by the number of teams and write your answer in decimal form. Now they tell us here that it's 32 teams, 12 make the playoffs. So number that makes the playoffs, and that's supposed to be divided by the number of teams. The number that make the playoffs is 12, and the number of teams is 32. Now they asked us to write our answer in decimal form, so we could just type this in, 12 divided by 32, and it gives us 0.375. Now number 13, it says, based on your answer to question 12, what percentage of teams make the playoffs? Now if you notice here, we have this decimal here, so we move 2 places to the right, which will give us 37.5%. Oh, hold on 1 second. Okay. So it would give us 37.5%. And that is basically it from page 7. Are there any questions before we go on to page 8? Okay, no question. All right, page 8. Because we're working virtually, we don't have to fill out problem number 1. So we will go straight to problem number 2. It says, let's look further into the idea of giving 110% effort. First, explain why a lot of people feel like saying that doesn't really make sense. Okay, the reason being is 100% is everything. You cannot give more than everything. So saying 110% sounds nice, but in actuality, whatever that person gave, and if it's all that they could give, they gave 100%. Hey, number 3, convert 110% into decimal form. Then multiply the result by 200 to find what 110% of 200 is. So 110% written as a decimal will be 1.10. So they're telling us to take 1.10 and multiply by 200, which will give us 220. So that means that 220 is 110% of 200. Now for number 4, it says, suppose that in a normal half-hour practice, A tennis player expends 280 calories of energy. How many calories would she need to expend if she were to give 110% effort? So basically, you're assuming that 280 is her 100% effort. So we had 280 multiplied by the 110%. That's supposed to equal to some unknown number. So we had 280 multiplied by 110% will become 1.10 equals x. 280 times 1.10 is 308 calories, because that's what we're counting here. And that would equal x. Now just to prove it on a calculator, 280 times 1.1. Oh, I hit divided by. That was my mistake. So it'd be 308. All right. Now we're actually almost done with 1-1. So we go here to page 9. So I got that a little out of the area. Okay. It says, now let's go shopping. If I had $1 for every time someone has asked me to calculate a discount price for them when the sign advertises a certain percent off, I'd be able to buy us both a very handsome gift indeed. In fact, shopping is one of the most common ways that people running loose in society are likely to encounter percents. My wife is an absolute wizard with Macy's coupons. As a high volume shopper there, she gets quite a few coupons in the mail. On one recent mall outing, she found a lovely red strapless number with a selling price of $79. She had 2 coupons to choose from. One offers $15 off any purchase of $50 or more. The other offers 20% off any item. Which was the better choice? Find 20% of $79. So first we would change this percent to a decimal. So it'd be 0.20 times 79. Now we put this in our calculator. So that would give us 15.8, or basically $15.80. Now keeping in mind that you just found the amount the price would be discounted, which coupon could Kat have used? Should have used. Okay, so we believe that the 20% off, she gets 80 cents more off the price. Number 7, the sales tax in our county is 6.5%. Find the amount of tax on the dress purchase after applying the coupon that you chose and the total cost including tax. Okay, so it's $79, and that is from up here in the directions. That is $79. And then we will take our 20% off, which is $15.80. So that'll be 3. So let me rewrite this. So this will be a 283. So it'll be $63.20. $63.20. Now, we're also told that you have to pay the sales tax for the county. So what they want here, they wanted you to find the amount of tax on the dress purchase and then the total cost including tax. So now, we know that with the discount being taken off, it's $63.20 that'll be taxed. So we'll multiply that by the 6.5%. So that'll give us approximately $4.11 sales tax. So that's how much you would pay in sales tax. Now they ask us for the total cost. So the total cost, you add $63.20 plus the sales tax of $4.11. So it'll be $67.31. This will be the total cost. Okay. Now we move on here. Problem number 8. It says, it's common for stores to advertise a certain percentage off, then say discount is reflected in the marked price, leaving you to trust that you're getting the percent off that they claim. Suppose that a refrigerator is listed at 30% off with a sale price of $7.49. What would that make the original selling price? Okay, so they say you got 30% off. Let me see. All right, and the sale price is $749. So first of all we know, let's look at what we know. 30% off got us $749. So we don't know what the original value, the original cost of the refrigerator was. That's the first thing. Now, the next thing, we know that some value multiplied by the original cost would give us this $749, which would be the new cost. So now, if you think about this, if you paid full price for an item, no discount or anything, that means you paid 100% for that item. Since it's 30% off, that means that we would take 30 from 100. So really you're dealing with 70% of what the original cost was. So 70% of the original cost is supposed to give you $749. So this will become 0.70 x equals 749. Now you divide each side by 0.70. So we could put this in our calculator. Let's free up a little space here. All right, so we have 749 divided by 0.70. So that'll give us X would equal to $1,070. All right, number 9. It says a large latte at Shakey's Caffeine Shack usually sells for the low price of just $3.50. But today, Shakey has gone goofy and is offering it for just $3. Wow, why not just give them away? Is this a better offer than the 20% off the coffee shop across the street is offering? Okay, now there's an assumption here that the original price at Shakey's is supposed to be the original price at the other coffee shop. And then you're able to do the calculations. So, is it a better offer at Shakey's or the 20% off? So this is what we would do. You could do this a couple ways. And I want to use percent increase and percent decrease. So if we look here, this would be a percent decrease. because we're going from the higher number to the lower number. So a percent decrease, and this is the same formula for percent increase as well. You have the new value minus the original value divided by the original value. So again, it's a new value minus the original value divided by the original value. So we could take the new value is $3. Let's do Shakey's. Minus the original cost is $3.50 divided by the original, which would be $3.50. So this would give us a negative 0.50 over 3.50. Now, let's put this in the calculator. So if we round this, let's say we rounded this to 4 decimal places. It would give us a negative 0.1429. Okay, so now this only equates to, just forget about the negative sign because it's negative because the price is going down. But this only equates to a little over 14%. So let me approximate that. That'll be a little over a 14% discount. Now remember, the other coffee shop was giving you 20% off. So basically, the 20% off coffee shop is better. Now, down at the bottom here, you have two formulas, percent increase and percent decrease. We already went over percent decrease, but the formula is the exact same. The only difference between the two is that at the end, after you solve it here, you will get a negative sign if it's decreasing, but if it's increasing, you will get a positive sign. But when you write out a statement for this problem, you don't say that it's a negative when it's supposed to be decreasing. You're supposed to say that it went down and then had a positive value. So like me saying that it went down by 14.20%, you would know what I mean. All right. Now we come here to the back. It says, on July 24th, 2009, the federal minimum wage was raised from $6.55 to $7.25. Find a percent increase. So now we have percent increase is equal to the new minus the original divided by the original. The new value will be that $7.25. The old value will be the $6.55 divided by the original value, which is $6.55. Now, we will take the 725 minus the 655. And that will give us 0.7 in our numerator, divided by 6.55. Oh, so I typed a little bit too many of them. All right. Supposed to be divided by, oh no, that's right. Minus 6.55. And that will give us 0.7. So now we would do 0.7 divided by 6.55. So that would give us, if we round this to 4 decimal places originally, that would give us approximately 0.1069, which is approximately 10.69%. That was your percent increase. Now again, you set this up basically the same as you did percent decrease, except for one would be negative, one would be positive. All right, now we move on. We're going to skip problem number 11. We're going to go to problem 12. Now it says here, we would never ever accuse any advertisers of being deceptive. But let's just say that it's not uncommon for percents to be used incorrectly in marketing materials. Let's look at one such case to close our review of percents. A department store advertised that certain merchandise was reduced 25%. Also, an additional 10% discount card will be given to the first 200 people who entered the store on a specific day. The advertisement then stated that this amounted to a 35% reduction in the price of an item. Explain why the store marketing manager is either a liar or bad at math. Show calculations to back up your explanation. Okay, now remember you started off getting 25% off. Then it says here that an additional 10% discount card would be given. The reason why this doesn't work is because the extra 10% is off the 25% reduction. Not the original price. And I could give you a quick for instance. Let's say it's 25% off of $100. So if it's 25% off, you know you're actually only paying 75%. Because remember, if you paid the full price, that'd be 100%. So you'll be paying 75%. So you would take 100 and multiply by 0.75. 100 times 0.75 will leave you $75. Now it's saying take an additional 10% off of that. So if you're taking another 10% off, that means that it's 90%. So you had to take 75 times 0.9. And that will give you $67.50. That's how much you would end up paying with the 25% off and the 10% off. Now, let's test the theory about this manager or marketing scheme saying that it's 35% off. So if we take $100 and say it's 35% off, you know that means that we'll only be paying 65%. Because remember, 100% would be the full price. But since we're taking 35% off, that means that we're paying actually 65%, which is 0.65. And 100 times 0.65 is $65. So if you notice here, you end up paying an extra $2.50 for that. So it's not an actual 35% off. Now, I'll tell you this, a quick story. Before I started teaching at Jackson College, I used to sell Coach purses. I used to go to the outlet out at Birch Run, buy them at the reduced cost, and then come back and sell them. So one day I went there and they had 50% off. And then they said that you would get an additional 30%. So I was thinking that I was going to get 80% off initially. But then after calculating and seeing what was going on, it turned out that instead of having 80% off, it ended up being more like 65% off. which was a drastic change in the discounts that I thought I was getting. So you got to be careful of some of those little tricks that they use while you're out. Okay, now number 13. It says, in promotional materials, a company that increased their workforce from 1,000 to 1,500 workers claimed that they hired 50% more workers. A rival of theirs bragged about decreasing emissions from 1,500 to 1,000 cubic feet per day, claiming a 33% reduction. Which company is lying? Okay, so the first company is saying they had a percent increase. So we know it's new minus the original divided by the original. So the new value was the 1,500 workers. The old was the 1,000 workers. Or the original was 1,000 workers divided by the original. So 1,500 minus 1,000 is 500 divided by 1,000. 500 divided by 1,000 we know is 50%. Okay, now the next is a percent decrease because they said they lower emissions. So we still do new minus the original divided by the original. So the new value would be 1,000. The original value was 1,500. So this would give us a negative 500 over 1,500. Now we could put that over here, negative 500 divided by 1,500. Now we could change that to a fraction. Well, we see that this is about a negative 33% here if we round it to 2 decimal places. So it'd be approximately a negative 33%. So both are telling the truth. Now you could get technical and say that it's the reduction is a little bit more than 33%, but it's around that, so I would consider both of them telling the truth. Okay, so now we're done with 1-1. Now we have to move on to 1-2. And 1-2 starts on page 17. Now, with 1-2, our title is, Where Does the Time Go? Learning objectives is to complete and analyze a weekly time chart, review a variety of calculations that involve percentages, create and interpret pie charts by hand, use a spreadsheet to create a pie chart. Okay, now we go down here to the bottom. It says, where does the time go? I'm not asking in the philosophical way as in holy smokes, it's almost Halloween. Where does the time go? I'm thinking more literally. Where exactly does your time go? Have you ever kept track of what exactly you accomplish with the 24 hours you're given every day? If you have very limited funds, you have to be very careful about how you spend what you have. But we all have limited time, and not many people think about whether or not they're using that time wisely. What does the quote at the beginning of this lesson mean to you? Now that'll be a personal statement that you would write. And then number 2, it says write down the 3 activities that you think you spend the most time on during the average week. Don't think about it too much. Just come up with 3 off the top of your head. Now you could do that at your leisure. But we're going to move on to the next page here. It says, here's a sample time chart put together by a student who was interested in identifying the amount of time she spent for 1 week. Each hour is marked with C, time in class, H, time spent on homework, S, sleep, W for work, or O, other time commitments. In the portfolio portion of this lesson, you'll be asked to fill out a similar time chart on your own. For now, we'll analyze this chart. Now, I'm not going to have you go through and count each letter. I'm just going to give you the amounts for number 3. So class was 15 hours. Homework was 32 hours. Sleep was 54 hours. Work was 15 hours. And other was 52 hours. Now, when you added all these together, it gave you 168 hours. Now we come down here to problem number 4. It says without adding the hours in the table, I already did that, but how can you decide what the total number of hours should be? Well, you think about it. There's 7 days in a week, 24 hours in a day. So you could just take 7 times 24, and that's how many hours you're supposed to have in a week, which is 168 hours. Okay, number 5. Most college advisors will tell you that a good rule of thumb is to allow 2 hours of study time outside of class for each hour spent in class. Is the student that filled out the table in question 3 following this advice? Okay, so they say how many hours are spent in class? We go here. Class is 15 hours. So we take 15 hours and multiply by the 2 hours that's recommended. That would be 30 hours. Now they ask us, is a student spending that much time studying? Now, if you look here, homework is the studying time. So it's 32 hours. So we would say yes and 2 hours over. Number 6, it says use your results from question 3 and 4 to fill in the next chart with the percentages of hours in a week devoted to each activity. Round to the nearest percent. Okay, listen. I'm going to write the percentages in here. But at the bottom of this page here, these were the values. I'm going to put all of these values over 168. So we had 15 over 168. The homework was 32 over 168. Sleep was 54 over 168. Work was 15 over 168. And then finally, other was 52 over 168. These are the values that you have to divide and make these into percentages. It said round to the nearest whole percent. So that would mean that we should not have any decimals in our final answer for percent. So we would take 15 divided by 168. So we'll round that to 2 decimal places. So that'll be 0.09, which is 9%. Next, we'll do 32 divided by 168. Round to 2 decimal places, be 0.19, which is 19%. Next, we would do 54 divided by 168. And that would give us, rounded to 2 decimal places, that would give us 0.32, which is 32%. Now work is 15 divided by 168, which will give us, rounded to 2 decimal places. So it's basically the same as it was up here. It'll be 0.09, which is 9%. And then finally, other, we'll do 52 divided by 168. Rounded to 2 decimal places, that'll be 0.31, which is 31%. Now, number 7, studies have shown that college students get about 6.5 hours of sleep per night on average, but their academic achievement improves when students average 8 hours of sleep. What percentage of the hours in a week would be devoted to sleep if you get 6.5 hours of sleep per night? What if you get 8 hours? How is our friend from question 3 doing when it comes to sleep? Okay, so if you do 6.5 hours times 7 days, that would give you 45.5 hours of sleep. So we're going to take this and divide it by 168. And we're going to round this to the nearest whole percent. So we have 45.5 divided by 168, rounded to the nearest whole percent. First, it'll be 0.27, which would be 27%. So it's about 27%. Now we want to find out what the percentage would be for having 8 hours of sleep per day. 8 times 7, so they're saying 56 hours divided by 168. So we'll take 56 divided by 168. Now we will round this to 2 decimal places. So it'll be approximately 0.33, which is about 33%. So if you look here, the sleep this person gets is 32% of their schedule, but it's recommended that you get 33%. So we could say that 32% is close, but not enough. Yep, it's close, but not enough. All right, now we move on to the next page. We look here at problem number 8. Now, problem number 8 deals with degrees. It says a circle can be divided into 360 equal units of measure, which we call degrees. In other words, an entire circle is made up of 360 degrees. The degree symbol, well, that circle symbol represents degrees. Multiply the decimal form of each percentage in question 6 by 360% and put the results into the next chart. Round to the nearest whole degree. So basically, this is what they want us to do. Now, if you want to look back at the percentages, they're on the previous page. The 9%, 19, 32, 9, and 31%. But they're telling us to take that and multiply it by 360. And your answer will give you the amount of degrees. So I'm going to write all of this out. Now, when we multiply all of this, let me multiply this out. We have 360 times 0.09. Okay, remember, we want to round this to the nearest degree, so it'll be approximately 32 degrees. Now, one thing I like about Desmos is this here. Since the 360 doesn't change, all we have to do is change that decimal value. So it'll be 0.19. Round that, that'll be 68 degrees. Then change that 19 to a 32. That'll be approximately 115 degrees. And then we know work and sleep is the same amount, so it'd be 32 degrees. I mean, class and work is the same amount, so it'd be 32 degrees. And then finally, other, we change that 32 to a 31. So that'll be approximately 112 degrees. And that's how you would solve for the degrees. Okay, so now I believe we only have a couple more problems here, and then we can move on to 1-3. You need to turn to page 23. Now we have interpreting pie charts. It says a national survey on college students and work was conducted during the 2003-2004 academic year and reported on the website www.acenet.edu. The results are summarized in a pie chart. It says what range of hours worked was most common. Now the hours worked, they want the actual hours worked, which will be these three. So with the actual hours worked, the largest one was the 1 to 20 hours. Now it says what percentage of students work between 21 through 34 hours. It has here that it's 21%. Now it says how many degrees make up the angle for the sector representing students who work from 1 to 20 hours. So we know that that's 35%. And then we will have to multiply this by 360 degrees to get the actual degrees. So we could change the 0.31 to 0.35, and this will give us exactly 126 degrees. Okay, now we move on to the next page. It says number 5, on a campus with 7,500 students, on average, how many would you expect to work at least 1 hour per week? So look, just to make this a little easier, it said at least. That means that amount or more. The only category don't have one or more is the none, and that's 25%. A circle percentage-wise must equal 100%. So what we could do, we could take 100% minus that 25% for none, and know that it's 75% that's dealing with 75% of the students who work at least 1 hour. So we would take 7,500 and multiply by the 75%. 0.75, and that would give us 5,625 students. Okay, number 6. On the campus in question 5, how many students would you expect to work less than 21 hours? So they want us to look at less than 21 hours. There's only 2 categories that have less than 21 hours. It's the 1 to 20 and the none. So 35% and 25%, we need to add those two together. So that means it's 60% that works less than 21 hours. So we would take our 0.60 and multiply by the 7,500. And that would give us 4,500 students. Now, number 7, how do you think these results would compare with the similar survey conducted for this school year? Why do you feel that way? Now, this is not a typical school year because of the COVID that's going on. So I would think the amount of hours worked by students would differ because of COVID-19. So that would be my answer for that, because I couldn't see it being almost the same, and we're in the COVID era right now. but hopefully we'll be getting out of that soon. Okay, now we need to move on to 1.3. 1.3 is on page 31. It says it's all about style. Our learning objective is to identify and understand your learning style, and then to create and interpret bar graphs using a spreadsheet and by hand, and then to decide whether a bar graph or pie chart is more appropriate for a given situation. Now, when we go down here to the bottom, it says every student can benefit from finding out a little bit about his or her learning style in almost any area. Understanding your strengths and weaknesses is an important part of improving. Record the scores you found when taking the online learning style assessment from the online resources from lessons 113. Now, that's something you could do at your leisure. And they are correct. That would be beneficial to you, but is not required for the class. But let's take a look at the next page. It says a bar graph is a visual way to compare sizes of different values. Pie charts are great for comparing parts to a whole. Bar graphs are effective for comparing parts to other parts. In a bar graph, the length of each bar gives an indication of how the size of a quantity compares to other related quantities. The bar graph below shows the percentage of global internet users that visit the top 5 most visited sites in the world. Just by looking at the heights of the bars, we can see how the percentages for these sites compare. By looking more closely at the scale on the vertical axis, we can get a good estimate of the actual percentage for each of the top 5 sites. So number 3, it says, which site has the highest daily reach? What percentage of internet users go to that site on an average day? Now we can see here plainly that it's Google. And if we want to look at percentages, Google is a little under 50%. So I would say maybe about 48% to 49%. I'm leaning more to 49, but I give the benefit of the doubt if someone put 48. Okay, number 4. Which is higher, Google's daily reach or the combined daily reach for YouTube and Yahoo? Now let's look at the combined daily reach of YouTube and Yahoo. YouTube is about, I would say, it's close to 35. So I'll say about 32, 33%. Let's just go with the 33%. Okay. Then we go to Yahoo. You look here at Yahoo, it looks like it's almost directly in the middle. So that'll be about 24%. It's a little under the exact middle. So when we add these up, that'll be 57%. That is higher. So YouTube and Yahoo combined is higher than Google. Okay, number 5. I did some poking around on the internet and found that in an average day, about 690 million people visit Facebook. Based on Facebook's daily reach, how many people access the internet each day? Now remember, this is just talking about the top 5 websites. Now, let's see. Okay. So if we look here at Facebook, Facebook is about at 42%. So 40%, 42% of some number is equal to There's say about 690 million people visit Facebook. So it'd be 690 million. So 42% of people that access the internet will give you 690 million. Okay, so we divide each side by 0.42. And x, let's see if it's exact or approximate. So we have 690 million divided by 0.42. So if you notice here, we have this very, very long number here. It has this value multiplied by 10 to the 9. Since this exponent on the 10 is positive, we got to move this decimal 9 places to the right. So it'd be x is equal to 1642. 642 is the first 3. 857 is the next set of 3. And then 142. And then we have 0.9. Now, of course, if we want to write this as a regular number, because we can't have 0.9 of a person, so it'll be about 1642, 857, 143. And if we really put this out here, this would be 1,642,857,143. Now we look here at number 6. I also found out that an estimated 3.3 billion people are internet users. What do you think accounts for the big discrepancy between this number and your answer to question 5? It's estimates. Estimates. The calculations I used were based on estimates, which gives varying answers. Okay, now we have about, I think we have about two more pages to go, and we will be done with section 1.3. Now we go down to page 35. It says here, the Harris Interactive Polling Agency surveyed 2,094 consumers in October of 2012, asking which former president they would most enjoy having a burger with. The top 4 vote getters are summarized in the bar graph. Which former president had the highest percentage, and what was the percentage? It'll be Clinton, and the percentage looks to be about 22%. So you could do 22 or 23%, but I just chose 22%. Okay, now number 2. How many of the respondents would most enjoy having a president with the most having a burger with the most popular choice? So it's 2,094 customers. And Bill Clinton is at about 22%. So we'll multiply that by 0.22. And your answer would be approximately 461. And we could type that in here. 2,094 times 0.22. And we have to round it to make it a whole number, because you can't have a decimal of a person. Now it says, which 2 presidents tied in the poll? It looks as though Reagan and Lincoln. No, actually it's Reagan and Kennedy. Now Reagan and Kennedy. So number 4, how many people chose a president not in the top 4? Now, Remember, it was 2,094 people that participated in this survey. Now, these were the top 4 vote getters, so we need to get their percentages. So if you look at their percentages, let's see, we have Reagan looks to be about at 14%. Clinton, we said, was 22%. Lincoln is exactly 15%. And then if we look here at Kennedy and Reagan was supposed to be the same. So that'll be 14% as well. When we add all of these together, that would give us 65% when we add all of them together. So that means that if 65% voted for the top 4 vote getters, that means 35% voted for other presidents. Because remember, if everybody voted for the top 4 vote getters, it'd be 100%. So we would take 65% from the 100%, which would be 35%. So we had 2,094 times 0.35. So we had 2,094 times 0.35, which when we round it off, first of all, it gets 732.9, which we'll round off to 733. Now, number 5, it says describe how Ford performed. Oh, okay. It says the yearly net income or loss for the Ford Motor Company from 2007 to 2011 is shown in the next graph. Describe how Ford performed in 2008 and in 2010 in terms of profit or loss. Okay, in 2008, as you see here, it's a negative 15. And remember, the profit loss is in billions. So they lost 15 billion in 2008. Now, they said in 2010, if you notice, it's going up and it's a positive 7. So they gained 7 billion, should put dollars in front of here, in 2010. Okay, now we move on. Let me see. Okay, we don't need to do those pages, but we do need to do this last page here, and it'll be these last 3 problems. For comparisons involving more complicated data, a cluster bar graph can be used. This allows us to compare data values for information in multiple categories on one graph. The sample below illustrates the daily trade volume for 3 large tech companies on the NASDAQ market for a 5-month period in 2015. For problem 15, it says, which company had the greatest variance in trade volume over that period? Write a sentence. Okay, Apple. If you look here, Apple is the blue. You notice it went up and down. They had more volatility than the other companies because they look almost steady. Apple varied more than Microsoft or Intel. Okay, 16. Which company had the most consistent trade volume? Now, if I'm looking here at trade volume, it almost looks like Intel had the most consistent. They went down a little bit here or there, but it looked like Intel was the most consistent. So I would say Intel. Intel is the most consistent. It's the most consistent for trade volume. Okay, now problem 17. Which company had the lowest number of overall shares traded during that period? How can you tell? Okay, now, if you look here, The company that looked like the lowest looks like to be Microsoft, because except for in one place here, Microsoft was always the lowest. So, and then if you look here, there was no big spikes from Microsoft either. So Microsoft and Intel was almost the same in every category except for one here. And Intel exceeded Microsoft more often than not. So it would be Microsoft had the lowest overall shares traded because it was almost the lowest in each month. And that is basically it for chapter 3. I'm sorry, not chapter 3, section 1-3. So we covered sections 1-1, 1-2, and 1-3. So tomorrow we're going to cover sections 1-4 and 1-5. And if you have any questions, please email me and I will be sending out this video today. It should be available at about 5:30 at the latest, just in case you may need to look this over. And the other video that I made, I will post that as well. I will be sending that as well. Okay, it looks as though I'm getting a question. Let's see. I need to answer this last question here. Okay, yes, you need to turn in for the week. You will need to turn in sections 1-1 through 1-5 worksheets by Sunday.